Okay, so today I want to share with you the notes on density. These are very important notes because our first rubric, our Flinker rubric, is based on density, and it's all about calculating density. So you definitely want to take some notes, and feel free to review this as often as you need to. So when we're measuring density, we need to understand the definition of density, which is the ratio or comparison of mass to volume of an object. So it's how much mass the object has compared to how much volume the object has. And the way that we write this equation is mass divided by volume. The metric units for density are grams per cubic centimeter or grams per milliliter. So when you're going to find density, the first thing that you want to do is make sure that your mass is in grams, and that your volume is in milliliters or cubic centimeters. So you want to make your conversions first. So for example, if we have something that has a mass of 5 grams and has a volume of 10 milliliters, it's going to have a density of 0.5 grams per milliliter. Now what's very important to know is that we never leave anything in a fraction, because a fraction is just an unfinished decimal problem. So in science, we're always going to convert from a fraction to a decimal by dividing. We also want to know, it's important to note that objects tend to settle or sink based on their density. So objects with larger densities settle to the bottom, and objects with smaller densities settle on top of objects with larger densities. So if you've ever looked at oil and water or different things in a jar, you'll see them separate, and they're separating based on their density. So what about the density of water? We talked about that water has a density of 1 gram per milliliter. So objects with a density of less than 1 gram per milliliter will float, or we say that they have a positive buoyancy. So which object in the picture of the fish tank has a positive buoyancy? Right, the boat. And objects with the density greater than 1 gram per milliliter will sink, or we call that a negative buoyancy. So in the picture, right, where's the object with the negative buoyancy? It's right here, it's the anchor. And then objects that have a density equal to 1 gram per milliliter will stay suspended in the water column. And that's called neutral buoyancy, and right here, that's our fish. So again, our boat, which is floating, has a density of less than 1 gram per centimeter cubed. And we're saying centimeters cubed because it's a solid object. But remember, centimeters cubed and milliliters are equal to the same amount. Our anchor down here has a density of greater than 1 gram per cubic centimeter. Or you could say 1 gram per milliliter. And then our fish here in the middle, his density is equal to 1 gram per centimeter cubed. So that's why large ships are able to float. It's because of their density. So obviously a ship, it needs to have a large volume. It's made up of metal. It has people on it, luggage, all kinds of different things. And the way that it is able to stay afloat is because of the sheer size of it and the amount of air that's in it, because air is less dense than water. So how are we changing an object's density? The first way to do it is to change the object's mass or the volume. When you want to make the object's density smaller, you either increase the volume or you can decrease the mass. And the reason that you would increase the volume is, think about having an object, when you increase the volume, you're spreading it out. But if you're keeping the same amount of mass, you're spreading that mass out over a larger space. And so it's going to be less compact. So it's going to be less dense. if you're decreasing the mass, so you're keeping your object the same size, it's going to stay the same volume, but you're decreasing the mass. So let's say you have a jar of M&Ms and you start eating the M&Ms, so you're taking them away. So the volume, right, the size of the jar is staying the same, the amount of space that it takes up is the same, but you're decreasing the mass because you're taking out those M&Ms. You're decreasing your density, so there's less mass in the same amount of space. If you want to make the object's density larger, you either need to decrease the object's volume, so keep the mass, shrink the amount of size that the object takes up, or you want to keep it the same and increase the object's mass. So you take that jar of M&Ms and now it's empty because you ate most of the M&Ms, but you go to the store and you buy a new bag, and then you come home, you fill that jar now again with M&Ms, so you've increased the density. Now there's more mass or more M&Ms per the same amount of space. So here's an example of a submarine. So if you've ever wondered how a submarine works, how does it go under the water and then is also able to float? The way that it works is that when it wants to go to the surface, the submarine empties water from the ballast tanks, decreasing the submarine's mass because now it's filling with air instead of water, which makes the sub's density smaller and causes the submarine to rise. And when it wants to dive, it opens those same tanks, fills them with the seawater, which is increasing its mass and makes the density greater and causes it to sink. And then depending on how deep they want to go, they will let either some water in, or let some out to go higher or lower under the water, depending on where they want to be. And then and that's why subs can only go to a certain depth, because once those tanks fill, it can't get any denser, and the sub can't go any lower in the water. The second way to change an object's density is to change the temperature of the object. So those of you who've already had chemistry, so 8th graders, you'll probably remember, hopefully, that when you heat an object, what happens? It expands. Because remember we talked about in chemistry those molecules spread apart, and that increases the volume. And so it's making the density smaller because the mass is staying the same, but the volume is increasing because, again, those molecules are spreading farther apart. It's why heat rises, because the hot air molecules, or the molecules of the hot air, are spread further apart, so they rise because they are less dense than cold air molecules because they're more tightly compacted. They're closer together. When you cool an object, you can make its density larger, because when you cool an object, it contracts, so the molecules get closer together, making the object's volume smaller, which makes the object's density larger. Again, this is only affecting volume, it doesn't affect mass. So this is why cold air sinks and warm air rises. And again, this is only affecting volume. It's not affecting the mass.